What's up, geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're looking at lesson 2.3, postulates and diagrams. What we're going to talk about are a few different postulates, like certain rules, and then we're also going to be able to sketch and interpret those diagrams. The first thing we're going to fill out in our notes are each of these point postulates. So we have 2.1 all the way down to 2.7, so we're just going to take our time and go through these. If you need to pause the video at any point in time to catch back up, you can, but let's go on and get started. So any of the postulate rules, we're just going to write down in this column. And then these are just picture examples and description examples. A 2-point postulate just means through any 2 points, there exists exactly one line. So here's point A, here's point B, and through those 2 points is one line. Going off of that, the 2.2 line point postulate just means a line contains at least 2 points. So if you have 2 points, you can make a line with them. 2.3 is the line intersection postulate. If two lines intersect, then their intersection is exactly 1 point. So here we have line M and line N, and they are intersecting at point C. 2.4 talks about the 3-point postulate. Through any 3 non-collinear points, meaning not in a line, there exists exactly one plane. So if you're able to point out 3 points, like point D, E, and F, they are making one plane, and that is plane R. The plane point postulate just means a plane contains at least 3 non-collinear points. So this one, 2.4, kind of supports 2.5, and 2.5 supports 2.4. Our last two point postulates are about planes and how they intersect. If 2 points lie in a plane, for this one is called the plane line postulate. So if 2 points lie in a plane, like D and E, then the line containing them lies in the plane. So line DE is lying in the plane R. And then the last but not least is 2.7, plane intersection postulate. If 2 planes intersect, then their intersection is a line. So you can think about, here is plane S, and then plane T, and they both can be intersected by line L, okay? If you haven't had a chance to fill out the first section of your notes, let's pause this video right here, and then when you're done, click play. So example 1 says, state the postulate illustrated by the diagram. So this one, it shows 2 lines intersecting and then a point. So this is the line intersection postulate. And we're just going to write post for a postulate. For letter B, it says if this image, then this image. And we see how we have a line being intersected over 2 planes. So this one would be the plane intersection postulate. Okay. Continuing on, this one you might want to try to pause the video and try it on your own. It says use the diagram to write examples of the plane point postulate and the plane line postulate. So let's take time now to pause the video here. Think about what your examples would be, and then when you're ready, click play. Okay, for the plane point postulate, this is where we are looking at at least 3 points in the plane. So if we're looking at plane P, we have points A, B, and C all within the plane. So that would be considered the plane point postulate. The plane line postulate just means there's 2 points on a line and they're within the plane. So points A and B are making a line, and that line N is also within plane P. So number 1, still going off of that example, use the diagram in example 2, so this previous diagram, which postulate allows you to say that the intersection of plane P and plane Q is a line. That would be using the plane intersection postulate, just because it's talking about a line intersecting. Okay. Number 2, use the diagram in example 2 to write an example of the postulate. So the 2-point postulate, I would say that would be line N. So line N passes through points A and B. The line point postulate would be also starting with line N, but that is containing 2 points, A and B. And then the line intersection postulate, line N and line M intersect at point A. Okay? Going on to example 3, sketching a diagram. So we're going to sketch a diagram showing line TV intersecting at PQ, intersecting segment PQ at point W, so that TW is equivalent or congruent to WV. So first let's start with our line TV. And then a line segment, so here's P, Q, remember line segments don't have arrows at the end, is intersecting at point W. And I didn't write this perfectly, but we're going to show the mathematical symbol that TW is equivalent to WV, and I'm just going to put 2 tick marks for TW and 2 tick marks for WV. Okay. Now it says if the given information states that PW and QW are congruent, how can you indicate that on the diagram? Well, we can put tick marks on PW and QW so that they match. So if we did that, we would just put 1 tick mark for PW and 1 tick mark for WQ. Name a pair of supplementary angles in the diagram and then explain. Remember, supplementary have to be equal to 180 degrees. So we could say that angle TWP and angle PWV are supplementary because they make a straight angle. Okay, simple as that. The last few we're going to talk about are how to differentiate between collinear, non-collinear, and planes and where they're intersecting. So what we can do is read the situation and then kind of go through each one of these. Example 4, which of the following statements cannot be assumed from the diagram? Let's start here with points A, B, and F are collinear. Here's A, here's B, and here's F. They are collinear because they're on the same line. Okay, so check mark means it's correct. How about this next one? Points E, B, and D are collinear. This one is no because there's no line connecting them. They could be collinear, but they just have to have a line to connect them. This next one says line AB is perpendicular to plane S. Line AB is perpendicular to plane S because if we look at plane S, is here, and there is a right angle indicated. So yes, right angle is marked. Okay, but the next one, it says line CD is perpendicular to plane T, and that one is not because there's no right angle marked. Okay, I'm kind of getting things mixed in here, so I want to make sure I'm separating. Okay, the last one, it says line AF intersects line BC at point B. This one is correct because it is marked right at point B. And if we need to, here is AF, here is BC, and they are intersecting at point B. The next two are going to be continuing of this example. So let's pause the video, try it on your own, and when you're done, click play. Number 5, can you assume that plane S intersects plane T at BC? we can say yes because it is marked. Okay, you can see how plane T is this plane, and then plane S is this plane, and the line that is going through both of them is right here, BC. Okay. Explain how you know that line AB is perpendicular to line BC. So this one we have to look very closely. Here is AB, and here is BC. Okay. Now, AB is perpendicular to plane S, and line BC is on plane S, and AB, line AB, and line BC intersect at point B. So because all of those things happen, we can say that they are perpendicular. That's going to conclude our notes for lesson